በመቀጠል የምናየው equations of tangent plane and normal line to a given surface. Let's say we have a differentiable function f of x, y, z. Then equation of a tangent plane to the surface, ያው የታንጀንት ፕሌን ኢኩዌሽን ለማግኘት እንደምናውቀው ከአፕላይድ ዋን አትሊስት ኖርማል ቬክተር እና ፖይንት ያስፈልገናል። ኖርማል ቬክተር to the plane and a point on the plane. equation of normal line ደግሞ ለማግኘት a minimum of a directional vector which is in the same direction as the surface and a point on the surface. ስለዚህ በዛ መሰረት አንድ ሲምፕል የሆነ ኤግዛምፕል እናያለን። ስለዚህ ምንድነው እዚህ ጋር እንደ ኖርማል ቬክተር የምንጠቀመው in the case of tangent plane is the gradient, and again in the directional vector የምንጠቀመው in the case of the line it's the gradient. ስለዚህ መጀመሪያ ስቴፓችን የሚሆነው ለሁለቱም it's finding the gradient. The gradient of f of x, y, z is equal to fx in the I, fy in the j, and fz in the k in the given point. ስለዚህ እነዚህን ኢቫሉዌት ስናደርጋቸው ግሬዲየንታችን ይሄ ይመጣል ማለት ነው። is equal to 4 in the I minus 16 in the j plus 8 in the k. Let's assume this is the plane which is tangent to the surface, and this is the point given on the plane, and this is an arbitrary point again on the plane. This is the normal vector which is perpendicular to the plane. Then if we draw a vector from this point to this point, the dot product of two perpendicular vectors is always 0 as we know. ስለዚህ በዛ መሰረት የታንጀንት ፕሌናችን ኢኩዌሽን ማግኘት እንችላለን ማለት ነው። ስለዚህ if this is, let's say, an arbitrary point x, y, z, and this is the point given p, the normal vector dotted with the px will give us the equation of the plane. So 4 into x minus 2 plus minus 16 into y minus 2 plus 8 into z minus 4 is equal to 0. This will give us the equation of the plane, which is 4x minus 16y plus 8z equal to 72. Simplify ማድረግ እንችላለን ይሄንን። ስለዚህ let's say our plane is represented by pi equal to x minus 4y plus 2z is equal to 18. For the normal line ደግሞ, as you said, the directional vector u is the same as the gradient vector. So this implies that our vector u will be 4 in the I minus 16 in the j plus 8 in the k. From equation of a line, መጀመሪያ normal equation እንጽፈዋለን. x, y, z is equal to the arbitrary point which is on the surface, 2 minus 2, 4 is equal to some scalar multiplied by the directional vector, minus 16, 8. Then parametrically equationaችንን ስንጽፈው our line represented by, let's say, L, then x will be equal to 2 plus 40. Then y will be equal to minus 2 minus 16t, and our z will be equal to 4 plus 8t. This will be our equation of the line which is normal to the surface.